Okay, so in this video we're going to have a look at vectors. This is going to carry on from the GCSE vectors, so I'm going to link below some of the GCSE videos to make sure that you are nice and clued up on your vectors before getting started on this. But the question on the screen is the kind of vector question that we are going to build up to throughout this video. This one is pretty tough, but we are going to spend the video looking at a bit of an introduction to vectors and just making sure that you're nice and fluent on some of the basics to do with this. So with that being said, let's get started. Okay, so starting off with vectors then. Now when it came to GCSE, a lot of the vectors that we looked at were written like this, and they're written as what we call a column vector. And a vector can be used to describe the way something moves and changing in its position relative to an x and y axes, potentially if we are looking at it on a graph. And also we might use this word displacement in terms of a change in position as well. So we might mention that throughout the video, but ultimately we are looking at moving something using a vector. Now when it comes to this one on the left here, we've got 4 and over minus 2 in our column vector there. And if we were to draw a little diagram of that, and if we imagine a little starting point, let's say that's here, that would mean going right 4, that's what the 4 represents on the top. Remember, if it's negative it would move left, and then the minus 2 would move it down by 2. And we would end up in this final position. If we mark that with a slightly different colour, we would end up just here. And that's what that column vector represents. Now when it comes to vectors at A level, which is obviously what we're focusing on here, we can write this column vector in a slightly different way, and we do it using some different letters that are different to what we've used in the GCSE. Now in order to write this column vector in our new way of writing it, we're going to write it using the letters I and J. Now the top number is going to be our first one, so we're still going to say 4, but rather than saying it's on the top of a column vector, we're going to say that that's 4i. And that letter I just means left and right, so positive 4 means right, and negative 4 would mean left. So 4i means it's going right by 4. We then put with that our second letter, which we're going to use, and we use the letter J, and as it's going down to, we're going to put minus 2j. So that right there means exactly the same thing as our column vector 4 over minus 2, but we say that that's 4i minus 2j. So having this understanding and being able to link this 4i minus 2j back to that column vector is going to be really obviously pretty essential for moving forward in this. But there we go, there's our first one. So likewise with that, here we've got minus 3 over 1 as our vector, and again that would mean going from a starting point we would be going left by 3, and we'll put minus 3 there, and then going up by 1, there we go, and that would get us to our final position over here. And sometimes we can link these vectors together with a straight line there, and there we go, and there's our final vector. That's the actual movement that is done in that green line. So again, writing this in terms of I and J, well, we've got minus 3, that's going to the left, so we have minus 3i, and then we're going to go up by 1, so plus, and we'll just put j there, we don't need to put 1j. So minus 3i means it's gone left by 3, and then up by j, 1j just means up by 1. So there we go, there is our final vector there. So there we go, we can obviously draw them out and show a visual representation of it, but these are how we're going to be writing our vectors now as we move forward, and obviously just being able to link that back to the column vectors. Just before we move on, we're not going to disregard column vectors, we will still be using those, but the majority of the time we're going to be writing them in this new format. So let's have a look at a question. Okay, so this question here says, given that A equals 5i plus 2j and B equals 3i minus 4j, find 2 lots of A, take away 1 lot of B in terms of I and J. Now you can do this just from the I's and the J's, but we can also just rewrite this as a column vector and treat it in the same way that we did at GCSE level. So 5i plus 2j would be the column vector 5 over 2, and 3i minus 4j would be the column vector 3 over minus 4. And what this wants us to do, in the question, it wants us to do 2 A's, take away a B. And hopefully you remember from GCSE, we just do 2 of these ones, and we're going to take away the second one. So 2 lots of the A, take away the B. And it's quite simple. The 2 lots of our first vector A there just means we're going to double both those numbers. So that's going to become 10 over 4 when we times them by 2. So we'll rewrite that as our new vector, and then we're going to take away the 3 over the minus 4. And when we're dealing with column vectors like this, we literally just do the sums. We look at the top numbers, so we have 10 take away the 3, and 10 take away 3 is going to leave us with 7 on the top. And on the bottom there, we'll swap colours. We've got 4 take away minus 4. Obviously just being careful with your symbols there, because we are doing 4 taking away a negative number. So that's going to add 4, and that's going to become 8 on the bottom. And there's our final vector, 7 over 8. Now obviously it says in the question here that we want to write this in terms of I and j. So we're just going to convert that back into our new way of writing the vector. So we're going to say that's 7i, positive 7, so 7i, plus, and it's positive 8, so plus 8j. There we go, and there's our final answer. So there we go, there is a bit of an understanding there of obviously how we can move between the two ways of writing these vectors, and obviously just answering questions like we would at GCSE, but writing it in this new format. So here we go, let's have a go at a couple of these before we move on to something a little bit trickier. Okay, so there's two questions here, very similar to the one that we've just gone over. So have a go at both of these, pause the video there, and we'll go with the answers in a sec. Okay, so the first one, given that A is 2i plus 3j and B is 4i minus j, find 2b plus A in terms of I and j. So A, if we write that as a column vector, is 2 over 3, and the other one we've got 4 over, and it's minus j, so that's minus 1. There we go, and there's our two vectors. Now we want to do 2 lots of b plus a. So we're going to do 2 lots of that second vector there, which is the 4 over minus 1, and we are going to add to that the vector a, which is 2 over 3. And if we expand this first one, so 2 lots of the first one, we get 8 over minus 2, and again we're going to add to that 2 over 3, and then we just need to add those together. So 8 plus 2 on the top is 10, and negative 2 add 3 on the bottom there is 1, and there is our final vector, 10 over 1. Obviously not forgetting to write it in terms of I and j, so if we convert that into terms of I and j, we get 10i plus 1j, or just plus j. And you wouldn't be wrong to put 1 with the j, but you just don't need to. You'll very rarely ever see a 1 put with the j when you're actually answering questions, so it's best to get into the good habit of not writing them in. On to the next one, we'll do this one a little bit quicker. That first vector there, we've got 9 over 7, and the vector b there, we have 11 over negative 3. And we need to do 2 a's take away 3 b's. Let's write this out, make sure we do our working out. So we have 2 lots of 9 over 7, and we're going to take away 3 lots of 11 over negative 3. Now let's actually expand these out. So 2 lots of the 9 and the 7, we have 18 over 14, and we're going to take away 3 lots of this bracket here. Now what you could do is you could multiply by negative 3, but obviously then forgetting or remembering that you would then be adding them. So rather than doing that, I'm just going to triple the bracket and then take it away. So we're going to have 33 on the top and negative 9 on the bottom. There we go. And then again, treating the top numbers as we did before. So we have 18 take away 33. Obviously little questions like this, just be very careful with your sums. That is negative 15. And then on the bottom you've got 14, and again we're going to take away negative 9, so that's going to be adding 9. So 14 add 9 is 23, and there is our final column vector drawn. And then again, obviously with both of these, not forgetting we're going to write it in terms of I and j. So our top number is negative 15, so we'll have minus 15i, and our bottom number there is positive, so we're going to have plus 23j. And there is our final answer, writing that vector in terms of I and j. Right, there we go. So that's how we're going to be writing these, and that's how we're going to approach some of these questions. Hopefully that's enough of an understanding to obviously see the links between what you've learned at GCSE with column vectors and this new way of writing vectors in terms of I and j. Now we're going to have a look at some of these slightly harder questions, which are going to link in some of those harder vectors that you would have done at GCSE as well. So let's have a look at those now. Okay, so moving on to some of the slightly harder questions. Now this says here, given that A is 2i plus 5j and B is 3i plus 2j, find lambda, and we'll talk about this, if A plus lambda B is parallel to the vector I. Now this is a new symbol here that you might not have seen, or you might have seen it in some of the other topics, but certainly not obviously in this video yet. We've got that symbol lambda, which obviously links back to kind of what we've done at GCSE, where we're just looking for an unknown. So lambda is just an unknown. And in this case, it's a multiple of b. We could rename that as x if you prefer, but it's best to get into the habit of using these new symbols at A level. So lambda is just an unknown symbol that we're looking for. So obviously what this question is saying is that we're going to do a plus a certain amount of b's, and it's going to be parallel to the vector I. So obviously I is moving in a particular direction. Let's have a look. So I is going across, and in order for that to be parallel, we could have any other line going in the I direction. Obviously this could be 1i, this could be 2i, and they would obviously be parallel because they're both moving to the right or potentially to the left. So that's what we're going to have a look at matching up here. We'll have a look at how we approach something like this. So we've got A is 2i plus 5j and B is 3i plus 2j. Now it's a little bit more complex, this question, but we're going to have a look at how to approach it. So if we have a look at adding them together, which is what it's asking us to do here, A plus a certain amount of B. So we've got A to start with, which is 2i plus 5j, and we're going to add to that a certain multiple of B. So we're going to do plus lambda lots of, and we have 3i plus 2j. There we go. Now, if we think about this logically, it says it's going to be parallel to the vector I. So if we have a look at this here, at the moment we've got some j's in there. We've got this j on the left, which is 5j, which is going up by 5, and then we've got this one here, which is going up by 2, but of course there's a multiple of that that's going to move it up potentially more or less than 2. Obviously we could have a fractional amount in place of that lambda symbol. So thinking about what we need here, we need it to be parallel to the vector I. Now if it's going to be parallel to I, meaning it's only going to move left or right, then we can't have any movements going up or down. So we need these j's to completely disappear. And at the moment we've got 5j over on the left here. So in order to make sure that that is going to completely disappear, we're going to have to think about what number is going to have to go in place of lambda in order to make sure that that 2j essentially brings us back down by 5. So we need that 2j to equal minus 5 in order to eliminate those j's. So if we think about this as a bit of a process, we're going to have 2j, or lambda, multiplied by the 2j has got to equal negative 5. Okay, or actually just really just times by the 2. We don't really care about the fact that there's a j there. It's more about the number that's in front of it, so we can get rid of that. So that lambda multiplied by the 2 is going to have to equal negative 5. Well, that's easy enough. We can solve that like an equation. We can divide both sides by 2, and we'll get that lambda has got to equal negative 2.5, and that's negative 5 divided by 2. And again, we can write this working out down just here, so divide by 2. And there we go, there's our answer. Lambda will have to be negative 2.5, which obviously means we could actually work out the values of I, we could work out the resultant vector for I there, and then we could go about showing actually what it all adds up and combines to make. We've got the 2i on the left, it hasn't asked us to do this, and then we're going to do the negative 2.5 multiplied by the 3, well 3 times negative 2.5 would give us negative 7.5 lots of I, and combining that with the 2i there would leave us with minus 5.5i. So that would be our resultant vector, and minus 5.5i would move to the left by 5.5. Okay, so 5.5, or you could even put minus 5.5 there in terms of actually what direction or movement this is actually going in. So there we go, that's how we're going to approach a question like this. So we're just going to write it out, and in the next question you're going to see we are going to have to expand it and go a little bit harder than this, but there's just a little one just to get you into the flow of these sorts of questions and thinking about how we're going to make sure that these values, these missing values, match it up to what we're looking for. So let's have a look at one more. Okay, so this question says, given that A is 3i plus 4j and B is I minus 2j, find lambda if A plus lambda B, or a multiple of B, is parallel to the vector I plus j. That's a little bit more complicated because we've got I and j in there, but we'll have a look at how we approach this one. So to start with, let's write it out. So we've got 3i plus 4j, which is our A vector, and then we're going to add to that a certain amount of B, so lambda lots of, and then we have I minus 2j. And let's have a look and let's expand this out and see what we have. So we have 3i plus 4j plus, and if we times both of these by lambda, we get lambda I minus, and I'm going to put the lambda symbol after the number, 2 lambda j. You could write lambda 2j, but I like to put the numbers at the start. Now what we know is that that is going to have to be parallel to the vector I plus j. Now what's interesting about this one, and they're all like this, but the numbers in front of I and j are equal. They're both 1 at the moment. So we know that the numbers in front of I and j, in order for this to be parallel, those numbers have to be equal. And if we think about the vector I plus j, that goes across 1, up 1. And if I try and draw that as best as I can, it goes in this sort of direction here. Okay, that being across 1, up 1. Okay, there we go, we can draw that in, across 1, up 1. Now in order for that to be parallel, essentially if we think about lines and the sort of parallel lines, it's got to have the same gradient. So it could be that it's going across 2 and up 2. Okay, but it has to be going up and across the same amount, just like our original vector there, which is going across 1 and up 1. But it could be any number there that it's going across and up, but those numbers have to be the same. And if we think about what that means in terms of our working out here, we know that the numbers in front of I has to be equal to the numbers or pieces in front of j. So let's have a look at what pieces are in front of I and what pieces are in front of j. At the moment we've got 3 and a lambda in front of I, and on the other sides we've got a 4, a plus 4, and we've got a minus 2 lambda in front of that j there. So if we group these together and have a look at them, let's have a look. We've got 3i, add the lambda I, and we've also got plus 4j minus 2 lambda j. Now they're grouped together, and you didn't really need to do that, but it does sometimes help to see it. We're just going to have a look at those pieces in front. Obviously they're called coefficients, so we're going to have a look at the coefficients of I and the coefficients of j, and we're going to compare them and make sure that we can see what number is going to make them equal. So we're going to make a little bit of an equation here. So the numbers in front of I, we've got 3 plus lambda, and the numbers in front of j, which these are going to have to be equal to, so let's say, okay, well that's got to be equal to 4 minus 2 lambda. And just from doing that little step there, we've got an equation that we can go about solving. So if we get the lambdas on the same side and the numbers on the other side, we should be able to actually go about solving this. So let's add 2 lambda to both sides to get rid of that minus 2 lambda. And we can take away the 3. I'm going to skip some steps here just to obviously save a little bit of working out. So I'm going to add the 2 lambda over, so that's going to put 3 lambda on the left hand side, and I'm also going to minus 3 from both sides to get rid of this 3 just here. So they're the pieces I'm going to move, and that would leave us with 1 on the right hand side. 4 take away 3. So 3 lots of lambda has to equal 1, and we can solve that as an equation. We can divide both sides by 3, and we're going to get lambda equals 1 over 3, so lambda equals a third. And there's our final answer for that question. Find lambda, obviously to make sure that they're parallel. So there we go. Substituting in lambda would ensure that the coefficients of I and j are equal and therefore parallel to our line there. Okay, so there's one question. Let's have a look at another one. Okay, so this one is a little bit trickier than the last one we looked at, and you're going to have one similar to this to practice, where we have something like this, and let's read through it first. It says, given that a equals 3i plus 4j and b equals I minus 2j, find lambda if lambda a minus b is parallel to the vector I plus 3j. Now straight away before we get started, you can see this time the coefficients of I and j are not equal. The coefficients of j in this particular instance right here are 3 times bigger than the coefficients of I. And we're going to bring that concept in the last step, back when we were making them equal to each other. We're just going to think about how we're going to approach that, so we'll come back to that right at the end. But to start with, let's do it like we did on the last question. So we've got lambda lots of a, and a is 3i plus 4j. So we've got lambda lots of 3i plus 4j, and then we're going to take away from that, you've got to be careful with this one, b, and b is I minus 2j. Now as we're taking it away, I'm going to put this one I minus 2j into a bracket. Obviously it doesn't matter if it's a plus between them, but when we're taking away, as we're taking away both of those, we don't want to forget to take away the negative 2, and otherwise we might only take away the I. So do be careful when you're doing takeaways, particularly when you've got more than one piece that you're taking away, that you put those pieces in a bracket just to avoid any mistakes there. So let's expand this bracket out and then obviously change the signs on that second one. So we have 3 lambda I plus 4 lambda j, and then we're going to take away I and also take away the negative 2, which makes it plus 2j. And there we go, that's all of those pieces listed out. Now again, we want to have a look at the coefficients of I and the coefficients of j separately, so let's join them together. So we've got the 3 lambda I, and we've also got the minus I, so we'll just put minus I, and then we've got plus 4 lambda j plus the 2j. And if we have a look at the coefficients that we've got here, we've got 3 lambda and also a negative 1 in front of the other one. A little bit hard to highlight that one there when we don't write the 1 in, but we know that that's a 1 and we can write that in as when we get to it. Now the coefficients of the other one, we've got 4 lambda being positive again, plus 2. So let's write these out and see what we've got. Now I'm going to do it like we did before. I'm going to change this in a sec because what I'm about to write isn't entirely correct, but I'm going to say, okay, well let's set these equal to each other. So we've got 3 lambda minus 1, and we'll set that equal to 4 lambda plus 2. Now technically what I've written there is not mathematically correct, and this is where we're going to have to look back towards this just here. And that's because we know that the coefficients of j are 3 times the size of the coefficients of I. And at the moment we've said that they're equal. Now in order to work around that, what we could do is we could say, okay, well this side here, we need to divide that by 3. You can do that, and that's absolutely fine. Ultimately you're going to get to this next step that we're going to write, but we could say, okay, well we need to divide that side by 3. Or what we could say is, okay, well actually the coefficients of I, we're going to have to multiply by 3. And if we make the coefficients of I 3 times bigger, they would then match the coefficients of j, which are already 3 times bigger, if that makes sense. So let's just times this side by 3, so we'll stick it in a bracket, we'll times it by 3, and then the coefficients would be equal. So let's go about timesing that by 3, so the 3 lambda would become 9 lambda, and the minus 1 would become minus 3. So 9 lambda take away 3 has to be equal to 4 lambda plus 2. And now we've got a nice easy equation to solve. So let's solve this over here. So let's minus 4 lambda from both sides. That would leave us with 5 lambda. And let's add 3 to the other side, and that's going to equal 5. So 5 lambda equals 5, so 1 lambda when we divide by 5 has to equal 1. And there's our final answer. Right, there we go. So that's how we're going to approach these questions, and it's all about looking at the coefficients and making this little equation and making them comparable. So if the coefficients, or if there is only one letter, then we need to eliminate one of the other letters or one of the other directions. If the coefficients are equal, we can set them equal to each other and solve it. And obviously then if the coefficients are different, so we have something like I plus 3j, or maybe you could have, I don't know, 5i plus j, you would actually have to multiply one of the sides to obviously make them equatable, and then obviously you can do your equation from there. Right, so there we go. Let's have a look at some questions for you to have a go at. Okay, so here's your questions to have a go at. The one on the left is similar to the first one that we ran over, and the one on the right is similar to those second two. So pause the video there, have a go at these, and we will go over the answers in a sec. Right, okay then, so have another look at these. So we've got A is 2i plus 5j and B is 3i plus 2j. Find lambda if lambda A plus B is parallel to the vector j. So this time the vector's j, and that means it's just going to be parallel to something that's going up or down. So if we do lambda lots of A, let's write that out. We've got lambda lots of 2i plus 5j, and then we're going to add to that the vector B, which is going to be 3i plus 2j. Now in this scenario here, obviously we just want to be left with a certain coefficient of j, or a certain amount of j's. So we want to be able to eliminate the i's here. And as we have the 3i over here on the right, and we're going to have lambda lots of this 2i. So whatever lambda is, when we times it by 2, it's going to have to equal negative 3, otherwise it's not going to eliminate the i's in these vectors. So we know that lambda multiplied by 2, the coefficient of I, has got to be equal to negative 3 in order to eliminate those. So we can actually solve this as an equation. We can just divide both sides by 2, and we're going to get lambda is equal to negative 3 over 2, or as a decimal, negative 1.5. And there we go, there's our final answer for that first one. That's going to ensure that those i's are eliminated and we're just left with a coefficient of j. Moving on to the second one, Obviously, we've got a little bit more to do in this question. It says, given that a is 3i plus 4j and b is I minus 2j, find lambda if a plus lambda b is parallel to the vector 2i plus j. So obviously we just need to be very careful in this one because we've got 2i plus j, meaning that we're going to have to double the coefficients of j in order to equate them. So let's actually write this all out. So we have a, which is 3i plus 4j, and we're going to add to that lambda lots of the vector b, which is I minus 2j. Right, so if we expand that out and then we'll group together the i's and the j's. So we've got 3i plus the 4j plus lambda lots of I minus 2 lambda lots of j. Now let's group them together. So we have 3i plus lambda I, and we're going to have the 4j minus 2 lambda j. So looking at the coefficients, we have a 3 plus lambda for our coefficients of I, and for our coefficients of j we have positive 4 and minus 2 lambda. Now just like before, let's set these equal to each other and then we'll figure out what we need to actually multiply one of them by. But we have 3 plus lambda that we want to be equal to the coefficients of j, which is 4 minus 2 lambda. Now let's look back to it. It says it's parallel to the vector 2i plus j. So the coefficients of I are double the coefficients of j, so we're going to multiply the right hand side by 2. Now if we multiply the right hand side by 2, we can actually expand that out. So if we do that, let's see what we get. We get 3 plus lambda is equal to 8 minus 4 lambda. And now we can solve that as an equation. Let's add 4 lambda to both sides. That will give us 5 lambda on the left, and subtract 3 from both sides, and that will give us 5 over here on the right hand side. So we've got 5 lambda is equal to 5, so lambda is going to be equal to 1. And there we go, there's our final answer for that question. Let's just highlight that. And there we go. So obviously in that question there, obviously doubling the coefficients of j, just to make sure that we can balance them with the coefficients of I and solve our equation like we have on some of the previous questions. Right, okay, there we go. Let's have a look at our next question. Okay, so on to some of our final questions. We've got this one and one more to have a look at and then we're done. So this one says we've got 3 vectors. We've got a, which is p over minus q. We've got b, which is q over p, and c is 7 over 4. Given that a plus 2b is equal to c, find the values of p and q. Well, first of all, let's work out what a plus 2b is. So we've got a, which is p over minus q, and we're going to add to that 2 lots of q over p. And it says that that is equal to c, which is 7 over 4. Now, first thing to note here is obviously we have 2 unknowns. We've got a p and we've got a q. And there's a little hint in that, and whenever we do have 2 unknowns, sometimes we may have to look at simultaneous equations. There's a little bit of a hint in here that we may have to involve another topic within this question. So let's have a look. Now we need to do 2 lots of p and q. So we've got p on the top, and let's just add together that top line there, but also timesing that right vector there, the 2 lots of p over q by 2 at the same time. So we have p plus, and we're going to have 2 q's, as we're going to multiply that one by 2, and that's going to equal the top number over there, which is 7. Now if we have a look at the bottom line, we've got negative q plus 2 lots of p, which is going to equal 4. So negative q plus 2 lots of p is going to be equal to 4. And there we go, we've got 2 equations, both with p and q in, and we can use simultaneous equations to solve that. Now just for the purpose of making this look a little bit nicer, what I'm going to do is I'm going to swap over the q and the p just to make sure that they're aligned with our simultaneous equations. You certainly don't have to, but I think it looks a bit nicer when we line them up in the same way. So rather than writing minus q plus 2p, I'll write 2p minus q. So let's get rid of that, and we'll write 2p minus q. There we go, so we've got our simultaneous equations. Now in order to solve our simultaneous equation, obviously we need a similar numbered coefficient with either p's or q's. I tend to like to make the second one the same, so I'm going to times the bottom equation by 2, so that we have 2q for both of our equations. So we'll times that one by 2 and rewrite it. So let's have a look. When we times that by 2, we get 4p minus 2q, and that now equals 8. There we go, so we've got our 2 equations. We can forget about the one in the middle, In fact, let's just get rid of that one. Okay, we lost the q there. Let's get rid of that. There we go. And we'll solve it from there. Let's move this up just above. There we go. And we have different signs in these simultaneous equations, so we'll add them together. And let's have a look. We get 5p. The 2 and the minus 2q obviously disappear there, they cancel each other out. And we have 7 plus 8, which is 15. And there we go, nice and easy to solve then. P is equal to 3, 15 divided by 5. Now we've got our value of p. Just like with normal simultaneous equations, we're just going to substitute that back into one of these equations up here. So we'll sub it into the top one. So if p is 3, we get 3 plus 2q is equal to 7. We can subtract 3 from both sides. So 2q is equal to 4, and divide by 2, q equals 2. And there we go, we've solved that question. Just highlight our two answers there because we've got p equals 3 and we've got q equals 2. So something a little bit different there. Obviously we didn't write it in our normal vector way with our i's and our j's, but just goes to show you that we can actually have these questions involved with normal column vectors as well, with something a little bit different with simultaneous equations there. Now if you're not entirely clued up with your simultaneous equations, again I'll link that in the description as another little topic which was included within this video. Now we're going to have a look at another question. This is going to be the hardest one that we've looked at, the one that we showed, well, the one that we looked at the very start of this video. So we're going to have a look at that question now, and that is also going to be our final question. Okay, so as we already mentioned, we've already looked at this question right at the start. This is definitely our hardest question on here, but there's going to be a lot of the same skills that we've looked at throughout this video involved in this question, but there is one tiny little extra element within this one. Now, this would be about 5 marks in an exam, so there's quite a lot going on here. I would encourage you to just sort of have a go, see how far you can get, and see which point of this question you actually get stuck on. Then, obviously, you can just pause the video and restart at whatever point you are stuck, but that's what I would sort of suggest doing for this particular one. So if you are going to do that, pause the video now, otherwise let's have a go. So we've got the resultant vectors of a and b, and we've got our vectors a and b there, is parallel to the vector c. Find the value of p and hence find the resultant vectors of a and b. So the resultant vector is when we add them together, basically what happens when we do both of these vectors, which is essentially just adding them together. So let's have a look at what we get when we add them together. Well, we get 3i minus 2j, which is our vector A, and we're going to add that to our vector B, which is pi minus 2pj. And it says that that is parallel to the vector 2i minus 3j. So let's have a look, let's write that down over here. So 2i minus 3j is the vector that it's parallel to. Okay, so moving on from here then. Now we can group together the i's and the p's like we did before. Let's just have a look at what we have. So we've got 3i plus pi, and we've also got the minus 2j minus the 2pj. Now if they are parallel, the coefficients of I will have to be, and the coefficients of j will have to be within the same multiples of what we have over here. We've got the 2i and the 3j, or the negative 3j. So if we're looking at this here, we know that the coefficients of I, and let's have a look at what they are. We've got the coefficient of 3, and we've got the coefficient of positive p. And then for j, we've got the coefficient of negative 2, and the coefficient of negative 2p. And if we have a look at these as an equation, let's see what we get. So plugging these in, we know that 3 plus p has got to be equal to the coefficient of I in our parallel vector, which is 2. But of course, if it is parallel, and this is where the new little bit comes in, that can be any multiple of 2. So we don't know how many lots of 2 it is. So we're going to have to introduce a new letter here. We could use lambda if we wanted, or we could use the letter x. As we've used lambda throughout the video, let's bring lambda back into this question. So whatever multiple of 2 we have. Obviously 2i is the distance 2 in the right hand or left direction. Obviously being positive 2, it's going to go right. But if it's parallel, it could be, for example, 4 across. Okay, in which case lambda would be 2, but we don't know what that multiple is. So that's why we're introducing this letter here, and that's how we're going to go about solving this question, something a little bit different. Now if we look at the coefficients of j and do the same thing, we've got negative 2, take away 2p, and that's going to be equal to the coefficient of j, which is 3, or negative 3. But again, we don't know how many lots of negative 3, so that's going to be negative 3 lambda. Okay, so again, just like the last question, we've got two equations. They're a little bit nastier because we've got p and I've introduced lambda here, so if you prefer to have your equations with an x in, feel free to replace it with an x. But again, I want to just rearrange these so they're in a nice format and a way that we can go about solving them nice and easily. So I'm going to move the numbers to the right hand side and the lambdas over to the left. So if we do that for the top one. So if I move the lambda over, we'll have p minus 2 lambda, and that's going to equal, when we move the 3 over, negative 3. For the one below, let's have a look at rearranging that. So we're going to have negative 2p plus 3 lambda, and that's going to equal positive 2 when we move the 2 over. So again, I'm skipping a few steps here because I've added the negative 3 lambda over, and I've also added the 2 to the other side. Hopefully you're okay with that. So these are the equations that we're going to solve then. And now we just need to obviously get some coefficients. We'll go for the coefficients of lambda. We need to get them equal so that we can actually go about solving this. So we've got a 2 on the top one, 3 on the bottom one. So we'll times the top equation by 3 and the bottom equation by 2. So on the top there, we get 3p minus 6 lambda equals negative 9. And on the bottom, we have minus 4p plus 6 lambda, and that's going to equal 4. Now again, we've got different signs in our simultaneous equations here, so we'll add these two together. So 3p add negative 4p is negative p. The lambdas cancel each other out, and the negative 9 add the 4 is negative 5. So negative p is equal to negative 5, so positive p is going to equal positive 5. And there we go, we've got our value of p. We could even go ahead and find the value of lambda, but actually in this case we don't really need to. Now you might have solved this for lambda first, in which case if you did, you just need to substitute that back into your equation to get your value of p. So like if we wanted to, we could find our value of lambda here. We could sub it back into the top equation, either this one here or the one at the start, and we would have 5 minus 2 lambda equals minus 3, and solve that for lambda. Obviously, though, we've only been asked in this question to find the value of p, and there it is, p equals 5. So there we go, there's our final answer for that bit, and we'll highlight that off, and then we'll have a look at our next step here. So it says, and hence find the resultant vectors of a and b. Now, if we come back to our original resultant vector, which we put together up here right at the start, 3i minus 2j plus pi minus 2pj, we can actually sub our value p equals 5 into that and then find our resultant vector, what happens when we add them together. So if we get rid of some of this, and we'll have a look at actually doing that. So let's write up here, p equals 5, and we'll substitute that into our vectors. So then we will have 3i minus 2j plus pi, p is 5, so 5i, and then minus 2pj, well 2p is 10, so that'd be minus 10j. And if we simplify that all down, 3i plus 5i is 8i, and negative 2j, take away 10 is minus 12j. And there is our resultant vector, now that we know what p is. And there we go, let's highlight that off as our second part of that question. There we go, so something a little bit different. Obviously that question there was an extra little step in where we had to introduce lambda, just so that we were obviously understanding the fact it could be any multiple of those coefficients of I and j, the 2 and the negative 3. But an extra little step, and obviously a lot of the processes that we've used throughout this video. Some of these types of questions will come up in the next video on vectors in part 2, when we look at some more complex questions. But hopefully you found that useful and helpful as a nice introduction to vectors on this A-level course, and I will see you for the next one.